Hello and welcome to our next lesson, 7th grade, lesson 2-5. Today we're going to talk about operations with rational numbers. So let's go ahead and get started. We're going to start off with our anticipatory set. First of all, what we're talking about today is I want to talk about video games because I love video games so very much. All right, so a video game I like to play quite a bit. The point of this video, well, one of the things you can do in this video game is you run around and you are this really cool guy. He's got like a hood on. He's got like a little cloak. You do a lot of really cool sort of parkour stuff. And so basically that's my character there. And what you do in this game, there's a lot of things you got to do. And one of the things is you're very agile. You get to run around. You get to avoid a lot of things. You gotta complete challenges by running around things. So anyway, in this game, sometimes there's a house, things like that. There's a house there. There's got windows here, windows there. The game is very good about sort of putting in like bushes and trees and things like that. So there's a little bush forest there. There we go. It's got some trees. And in this game, here's a cool little tree branch. There we go. And there's the tree and blah, blah, blah. Okay. So in this game, it's based in the French Revolution. And you got to go around. It's very well made and everything. Now, there's also a lot of people in these video games. They're just always standing around, and sometimes they get in your way. So one of the things I had to do in this game was I had to go, there's this platform here where a guy was looking this way, and there was a table behind him, and on the table is a very sort of important document that I needed to get and give to my people. So there's a little document there. Now, this is one of the most fun levels. I brought it down a little bit because you have to really get there, and now this guy turns around every now and then. So if he sees you, he's obviously going to pick up the piece of paper, he's going to pick it up, he's going to run away, and you won't be able to get it. So what you have to do is you're starting out behind this house here, and you got to try and get over here, grab that, and get out of there before this guy turns around. You got like 15 seconds. 15 seconds is not a long time to get there. So what happened? Now, my friend likes playing this game too. We talked about this because there was a lot of different ways people were trying to do it and how it was getting done. So the way I did it, I always like to go up. I always like to climb over things and stuff like that. So what I did is my sort of strategy of it was I would run here and jump up, and this guy could actually jump up, and he's agile enough to sort of get up onto the house here. He's still got his little cloak on, so that's me. So I would jump up there, and then I would run across the top of the house, and I would jump here, and I would land, and I would try and catch. Let's see, here he is, holding on to that, get that, and then I would swing and use my momentum to sort of go up into the air, sort of do like a flip to get over these people, and then I'd land here, and I'd get that, and then I'd run away. So that was always my sort of technique, my way of doing it. My friend, who he was never really good at jumping up on top of things, running off trees, running off the top of houses, doing these things in the air. He liked to do a lot more running through things, stay along the ground. So what he did is he would run this way, and he would sort of jump, throw himself through this sort of house right here, sort of swinging through. He would land and then jump back out this way, sort of dive out, do a little roll, jump up over this, jump up over that, sort of vault him over, and then land here. And then what he would do is he would sort of sneak into these people and stand here. And then the guy would turn around and look, but he was hiding in these people, and then he'd turn back around and look that way. You have another about 15 seconds. So he would sneak through, and he would jump up, and then he would do the same thing I did. So in the end, we both got it. We both had two different ways of doing it, but we took our different steps and we did our different sort of things, and eventually we both got sort of the same result. No matter which way you went, you could go up here, jump over the tree, flip over people and do it, or you could slide through here and jump through those people and do it. It's one of the most fun games I've ever played, so very excited to talk about it. But anyway, let's go ahead and get into our actual math for today. So let's go ahead and start with our standard. We're actually going to write down 2 today. I'm going to go ahead and talk about 2. And the first one is 7.NS.2c. And yes, we have done this one before. We've talked about this one. I believe it was maybe the last one, 2.122. But this one says to apply properties of operations as strategies to multiply and divide rational numbers. And that's it. Not a very long one. We're going to use properties of operations. So we got to think back and remember what those properties of the operations were. And then we're going to take those and we are going to use multiplication and division while using those operations. The next standard is a little short. It's a short one too, 7.NS.3. And again, we've talked about this one before too. This one says to solve real world and mathematical problems involving the 4 operations with rational numbers. Okay, so this next one says to solve real world and mathematical problems involving the 4 operations with rational numbers. So those 4 operations are just multiplication, division, addition, and subtraction. And we'll see how those sort of fit into everything as we get going here. So those are our 2 standards we're going to be talking about today. Let's go and talk about some input. And we've heard a lot of these terms before, but we're still going to write a few down. And there is actually going to be a pretty new one that we don't talk about all that much. So we're going to get that down. Our first term is going to be order of operations. And we should be very good at the order of operations already. We know what the order of operations is. But we're going to go ahead and write down just the steps. We don't need a definition. We just want the steps. And today we're going to focus on, number 1, we're going to evaluate expressions inside grouping symbols. It's always the first thing you do. No matter what the type of operation is, you're going to always work on the grouping symbols. What is grouped together? Then the second step is just to multiply and divide from left to right. Easy. We learned that way back in, I think, 3rd grade. And then our third step is to add and subtract from left to right. So we should know that. That should be almost second nature to us at this point. The next thing that we also do know and we've used before is the distributive property. And the distributive property, we've written down the definition of it before, but I just want to go ahead and put what it specifically states. And really, it just is saying that A times the quantity B plus C is the same thing as saying A times B plus A times C. Same thing as saying that. In the same way that A times the quantity B minus C equals A times B minus A times C. So that's the distributive property. It's just that basic principle that we do understand at this point. Now, something that might be a little new for us is this next one, which is called a complex fraction. A complex fraction. Now, a complex fraction, this one's a little bit more difficult. A complex fraction is a fraction, obviously, right? Complex fraction is a fraction, A over B, where A and or B are fractions and B does not equal 0. All right, so these complex fractions look very strange, but they're a fraction where either the numerator or the denominator is also a fraction within a fraction, almost like inception. So let's go ahead and take a look at what this may look like. This could look like negative 3/4, 3 over 4, over 10. It looks weird. You don't normally see that. And it's important to know that this right here, that fraction bar, is not the main fraction bar. And you need to be very careful and be able to tell which one is not the main fraction bar, because that one is the main fraction bar. So because we can understand that, then this becomes a little easier because of this next thing we're going to write down for this. A complex fraction is this, and it may look like that, but also a complex fraction can also be written as division, meaning that this complex fraction up here can also be written as negative 3 over 4 divided by 10. Because we know that fractions are the same thing as division. So that's it for our language of the discipline. I'm out of space on my paper, so I'm going to go ahead and grab a different one. All right, so let's go ahead and get started on our details. So go ahead and draw your flower. And then let's go ahead and get into what we want to talk about today. The first thing, we're actually going to use one of our icons here. So right in the middle of your paper, up on the top, go ahead and draw your best glasses that will represent different perspectives. So we're going to look at the same problem in 2 different ways. Now, since I'm a huge Broncos fan, I'm going to go ahead and use blue for one side and orange for the other. So my orange side is going to be operations. Operations, okay? And everything else I'm going to use as black here. Operations versus the distributive property. Okay, and then along this versus, I'm going to go ahead sort of draw like a dotted line going down there a bit. Okay, so on one side, we're going to look at a problem using the order of operations. And on one side, we're going to look at the distributive property, and we're going to see if they are the same thing. We're going to prove that they're the same thing because you've learned the way to do the distributive property, and you've always known how to do the order of operations. So now let's go ahead and take a look at what this would be. So on my orange side, I'm going to write an equation, okay? And I'm going to write it backwards so I can sort of space it out the right way. So that's negative 4 there. added 2, and then we're going to put a 2 here, add, I'm going to put a 3 there, and then we're going to put a -5 in the front. Okay, so that right there says -5 times the quantity 3 plus 2 plus -4. And that is going, we're going to say that that needs to be equal to the blue side over here, which I'm going to write the exact same thing. -5 times the quantity 3 plus 2 plus -4. Okay, so we have the same thing. So right now, I've proven that these two things are the same. I haven't solved them, but since they are the exact same, they have to be equal. So let's go ahead and do our order of operations side first, okay? Order of operations side first. And the first thing that we're going to do, so our first step would be grouping symbols. Grouping symbols. So we're going to do grouping symbols first. And what grouping symbols am I talking about? Well, there is parentheses right there, right? That's a grouping symbol. Now this one over here is already grouped and it's already simplified. So we're going to simplify our grouping symbols first. So this orange side, this order of operations side, is now going to become -5 times 3 plus 2, which we can all know is 5, plus -4. Okay, so based on the order of operations, we've done number 1, which is to evaluate expressions inside grouping symbols. Now, the super easy stuff, and we're just going to get easier and easier as it goes. Step number 2 is going to be to multiply from left to right. So let's go ahead and multiply anything we need to multiply from left to right on the orange side. -5 times 5. We know what that is because 5 times 5 is 25. They're different symbols. That means it's going to be negative. So we're going to have -25 plus -4. And that's our multiplication. And now again, the easy part. Number 3, our third step, is going to be to add from left to right. Okay, well, adding from left to right, -25 plus -4, we're adding more negative to the already negative number, meaning we're going to get to -29. And that is our answer. Nothing really that we don't know how to do. That's how we use the order of operations and solve this side. Okay, so that's, let's say, go back to our anticipatory set. That was my way, right? Jumping over things, flipping over, getting up there. Let's take a look at another way. Okay? Now on this blue side, we're going to do the distributive property. So obviously in the distributive property, your first step is to distribute. And what are we going to be distributing? Well, we're going to be distributing this -5 to the 3 and this -5 to the 2. And so my new equation, and you know what? Let's put a one. This stuff should be equal, right? Because we're using it. We already knew it was equal from up top. So we need to prove that this is equal. So let's see. Now this is going to become -5 times 3 plus, because there's an addition sign, this is a positive number, plus -5 times 2 plus -4. Okay, now we go down to the easy things again. Step 2 is to multiply. We're going to multiply left to right, things that we need to multiply. So let's look right here first. -5 times 3, those symbols are different, so I know it's going to be negative. 5 times 3 gives me 15. Plus -5 times 2, those symbols are different, so it's going to be negative. 5 times 2 gives me 10. And then there's no multiplication to do here. There we go. Now number 3. We are going to add. Let's see if we can prove that this is the same. Well, let's add from left to right. -15 plus -10. So we're adding more negative. -15 plus -10 is going to give me -25 plus -4. Okay, so it looks like we have another step here. So let me go ahead and put another equal sign. This side is still going to be negative 29. This side, let's see, we're still going to add negative 25 plus negative 4. We're taking negative 25 and we're adding more negative to it, meaning we're going to get negative 29. And I see we've done two different ways, order of operations and the distributive property, and we see that both of them equal the same thing. So we can prove that both of those do work right there. So that's, again, math. You can answer it so many different ways. If one way makes more sense than the other, make sure you're using that way. Just like this. I'm better at doing this one. This person's better at jumping through here, sitting right here waiting, taking one more step, and getting that. So it's up to you how you want to go about doing this. Okay? Let's go ahead and let's do something with real world problems. Okay? Real world problems. Real world problems. Okay. And let's take a look. One of these things in the real world that we can talk about is temperature. Remember, the standard is saying that we want to take these real world problems and use our operations, right? So one thing you can do with temperature is you can change Celsius to Fahrenheit. You can change Celsius and make it Fahrenheit. Now, when you do this, you are going to be given an equation. You're going to be given a formula. And the formula is Fahrenheit equals 9/5 Celsius plus 32. Okay, so that's the equation, or that's the formula we use to change Fahrenheit to Celsius. So let's say, for our example, for what we wanted to do, let's go ahead and use a different color. Let's use some nice light blue right here. We're taking the temperature of negative 10 degrees Celsius, and we want to know what degree is that in Fahrenheit. How many degrees Fahrenheit would negative 10 degrees Celsius be? Okay, so once we have this, we're going to take our time. We're going to go step by step. So let's go ahead, and with everything, we're always going to write out our equation. F equals 9/5 C plus 32. That is our equation, or that is our formula. And our first step is to substitute negative 10 for C. That's our first step. So we're now going to take F equals 9/5. Now we have something we're inputting into this. Negative 10 plus 32. Now we can solve and find out what the Fahrenheit would be. So we're going to need, first of all, since this is going to be some multiplication, our next step is going to be, we're going to write negative 10 as a fraction. Write negative 10 as a fraction. So now we have Fahrenheit equals 9/5 times, and the way we write negative 10 as a fraction is just negative 10 over 1 or negative 10 over 1. Anywhere you put that negative, the whole thing will be negative, plus 32. Okay, so we're getting there step by step. Then we know, because you can see that there is a positive times a negative, that will equal a negative. So this positive and this negative, so when we multiply those, that's going to give us a negative. So now Fahrenheit equals negative 9/5 times 10 over 1 plus 32. And then our next step in a problem like this, a real world problem, would be, okay, what do we do next? Here, we divide common factors. So I'm going to look here and I'm going to say, okay, well, 9 and 1, I can't do anything there, but 5 and 10, 5 goes into 5 one time, 5 goes into 10 two times. Okay, let's see what we have right now. Fahrenheit equals negative 9/1 times 2/1. Oh, that's much easier to work with. Okay, let's move to our next step. What else? What would I do then next? Well, now I've finished everything I needed to do up here. It's as simple as it's going to get. Let's just get down to our basics, which is to multiply. So now we have Fahrenheit equals, we're going to multiply 9 and 2 over the top, which is 18. 1 times 1 gives me 1. So this is going to actually be negative 18. Nice and easy, right? Plus 32. All right. Now the super easy part. Add. And you just add those, which means we're going to have Fahrenheit equal 14. So all that work, all those different steps, all those different pieces, got to jump here and then jump here and then move. You got to go through each step nice and carefully, but at the end, you can find out what we wanted to know. So we were wondering, 10 degrees Celsius is what degrees Fahrenheit? Well, negative 10 degrees Celsius is 14 degrees Fahrenheit. So that's a real world problem. I give you this formula and I give you a degree in Celsius and you need to find me the Fahrenheit. Now you can also obviously do this the other way because we have something C equals 5/9 times the quantity F minus 32 is used to convert Fahrenheit to Celsius. So there's another way to do that. It's just the opposite formula that we use to go the other direction. So there's a real world problem. Many times, and you'll see this in the guided practice, they'll give you the formula and you're going to go ahead and use that formula. You just need to plug things in, think about the real world problem, and solve your formula, solve the equation. Now, let's get into our last little bit of our input here. Let me go ahead and use a different piece of paper. All right, now we get into the fun stuff. And that fun stuff is complex fractions. And complex fractions just look weird, but once you figure out that you can use division with them, they get much, much easier. So the first thing we need to remember, I know I wrote this earlier, but we're going to go ahead and write it again. Fraction bars can represent two things. The two things they can represent are grouping and division. Fraction bars can represent grouping and division. So let's first take a look at an example of how it can represent division. And we saw that as an example when I put this down as a term. We're going to write one out. So let's go ahead and do this. Let's go ahead and solve this. Negative 5/6 over 15/2. Okay. So as you can see, we have two fractions. Very weird looking problem. Don't like it this way. This, however, is a way of showing division. That is a way of showing division right there. So let's write this out in a much better, easier way. Let's go ahead and say this is now going to be negative 5/6 divided by 15/2. over 2. Now, again, I don't like, there we go. Again, I don't like this either. I don't like dividing fractions. But there's a much easier way that we've learned before. I believe you learned this all the way back in 5th grade. And when you divide fractions, you can also multiply by the reciprocal. So let's do that. Multiplying fractions is so much easier. So let's go ahead and say negative 5 over 6 times the reciprocal of this, which is going to be 2 over 15. Then the next step of this is you're going to look. If you're multiplying two things, and one is a negative and one is a positive, we know that that's going to automatically be a negative. So let's get that negative out of the equation. We know that's going to stay there. And then 5 over 6 times 2 over 15. Now we can just worry about the numbers. Now the great thing about this is now we can cancel out some of these factors right here. 6 and 2, great. Those we can find a multiple there. 2 goes into 2 one time. 2 goes into 6 3 times. Same thing this way. 5 goes into 5 one time. 5 goes into 15 3 times. Oh, much, much simpler. We now have negative 1 over 3 times 1 over 3. Okay, now let's just go ahead and multiply. We know the answer is going to be negative, and then let's multiply the top. 1 times 1 gives us 1. 3 times 3 gives us 9. And our answer is going to be negative 1/9 because that's as simple as it's going to get. So this over here, super complicated, confusing, not sure how we're going to do it, but you can just break it down, make it things that's easier to do, and we're going to get all the way there to our answer. Let's look at another one. Now that's how we can use division when we have a complex fraction. What about grouping? We had something like 2 plus 4 over 1 and 1/2. Well, we know because we're just looking at it that this right here is going to be division. And when something's on top of a fraction bar, you're always going to go ahead and do that first. So this right here is grouping. All right, well, that's going to make things easier. When we write out our new equation, it's going to look like this. It won't just be 2 plus 4 divided by 1 and 1/2, right? Because if we did that, we would have to do the division first. Since it's on top of the fraction bar, it's as if it was grouped. So we have grouped those together. Now that becomes a lot easier. Also, this right here, we don't want to be dealing with any mixed numbers right now. So the simple way to remember how to make this mixed number into a improper fraction, which I know you know, we're just going to do it. 1 times 2 gives us 2. 2 plus 1 gives us 3. And that's going to now be 3 over 2. So our new equation after this is going to be 2 plus 4 divided by 3 over 2. All right. Now easily, let's just go ahead and get our addition done because that's in the grouping symbols. We'll get that done first. 4 plus 2 gives us 6 divided by 3 over 2. And as we saw before, we don't like to divide. We like to multiply by the reciprocal. We want them both to be fractions. That means our 6, we're just going to go ahead and put that over 1, and we're going to multiply by the reciprocal. 6 over 1 times 2 over 3. Much better. Then, luckily, well, 2 and 1 we can't do anything with, but 6 and 3, we can find multiples there. 3 goes into 3 one time. 3 goes into 6 2 times. And our answer is now going to be 2 over 1 times 2 over 1. Oh, that's so much easier. So our final answer is going to be 2 times 2 is 4 over 1 times 1, which is 1. So we can just go ahead and write the number 4. We don't need to put it over 1. And that is going to be our answer. Okay, so that's just two ways to look. Even though the complex fractions look complex, you do need to do a little bit of work and write it out, but it's nothing new. It's nothing crazy that we're learning. It's just taking our time and doing the operations that we know. Okay, let's move into our modeling. We're just going to go ahead and do two modeling questions today. And our first modeling question, number one, is just going to be, it's not a real world one. This is just going to be mathematical, which is one of the things we need to know how to do too. So this one's going to be -3 times the quantity of -2/5 minus 8. Oh, there we go. All right. Now there's two ways you can approach this, right? Like we looked at when we were doing this right here, a little different perspectives. You can do it with operations or you can do it with a distributive property. For me right here, since there's a fraction right there, I'm going to go ahead and do this with the distributive property. So what I'm going to do is I'm going to go ahead and distribute my -3 to both that are included in that grouping symbol. And that's going to give me -3 times -2/5 plus -3 times -8. All right, then our next part, we have a multiplication problem. That's pretty simple over here. And then we have something where we need to convert our -3 into a fraction first. So let's take a look. First of all, let's see. This is a negative and that's a negative. So we know that the resulting term is going to be a positive. So we don't have to worry about that negative sign anymore. In parentheses, we can make 3 into a fraction, and we're going to multiply that by 2/5. The reason our negatives are gone is because since they were both negatives, now we can treat it like the product, which will be a positive. And then we can go ahead and make sure we've done this equation or this multiplication over here. -3 times -5. Those are two negatives together. The signs are the same, meaning the answer is going to be positive. So 8 times 3 is 24. Okay. Now before we move on, what we can do, is there any way for us to cancel out with multiples? 2 and 1, no. 3 and 5, no. So we're just going to have to multiply straight across. Meaning, we're going to get 3 times 2, which is 6, over 1 times 5, which is 5, plus 24. Now we have an improper fraction right here. So we need to make sure that we make that in a mixed number so that we can actually do this here. 6 over 5, that means 5 pieces of 5 and 1 left over. So it's going to be 1 whole set of 5, 1, and 1 left over 5 plus 24. Now we're at the very end. 24 plus 1 and 1/5 is just going to be 25 and 1 over 5. And that's going to be our answer. Whew, almost ran out of room on that one. Excellent. So that's just anytime we're doing these mathematical problems, there's going to be several steps. You just need to take your time, go through. If you forget which order to do things in, it's always right here. Your grouping symbols, your multiplication and division, you're adding and subtracting. Same thing with your distributive property. You're going to use those same rules. Okay. Let's do our second and our last modeling question for today. And this one's going to be more real world related. So the water in a pool lowered by 3/4 of an inch over 2.5 days. what was the average change per day? All right, so we're looking at this. That's a pretty complicated question. If the water in a pool lowered by 3/4 of an inch over 2.5 days, what is the average change per day? Now, we didn't do a whole number of days, 2.5 days, 2 full days and then half of a day. And over that whole time, it lowered by 3/4 of an inch, 3/4 of an inch. So we need to divide 3/4 of an inch over the entire span that we're looking at, which is 2.5 days. That, if you've been paying attention, is going to create a complex fraction, which is going to be our 3/4. But look, we're lowering, so that's going to be negative 3/4. And we're going to divide that by 2 1/2. So our 3/4 of an inch that we lost over the 2.5 days. Now we know we can just split this into division because that fraction bar creates a division problem. Negative 3/4 divided by 2 1/2. Now what we need to do is we need to convert this into an improper fraction so we can really deal with it. So the best way for me to remember that, I know some people have their own ways, but for me, I just take the whole number and I multiply it by 2. So that's going to give us 4. I take what's left and I add that last to it, like that little circular look. For me, that helps. So we are now going to have negative 3/4 divided by 5/2. Now, there's a few things we can see here. The first is that we're not going to want to divide. We're going to want to multiply by the reciprocal. So let's just go ahead and write that out. Negative 3/4 times 2/5. Much better. And the second thing that we can find out here is that since this is a negative sign and this is a positive sign, the signs are different, meaning our answer is going to be negative. So let's just put this in there now. 3/4 times 2/5. Let's see if there's any factors, any ways for us to get a multiple and factor that out. If I look right here, 3 and 5 can't work, but 2 can go into 2 one time, and 2 can go into 4 2 times. So now we have a negative 3/2 times 1/5. Oh, I'm going to run out on this one. Luckily, we're just finding our answer now. So 3 times 1 will get, so our answer is going to be negative. 3 times 1 gives me 3 over 2 times 5 gives me 10. There's no way for me to simplify that, so all I need to do is add inches. So how many inches did the pool lose every day? It lost 3/10 of an inch every day. That means over the course of 2.5 days, it would have lost 3/4 of an inch. All right, so there's our real world problem dealing with those complex fractions. Okay, so remember, please, when you're doing your guided practice and you're doing your independent practice, take your time. This stuff does take some time, but you can't rush it. You really can't rush it. All right, our guided practice is lesson 2-5, guided practice. Our independent practice and yes, we have done this independent practice on front row ed before, but it's always, we want to get that extra practice. All right, so you're going to go to front row ed and you're going to do standard 7.NS.2c. So go get your work done on that, and that is everything I have for you today. Great job and go Buffs.